If you remember from the periodic table video, we talked about that in our periodic table, we get metals to the left and non-metals to the right. Now, bonding is divided into three: ionic, covalent, and metallic. Why do elements bond or atoms bond? They bond to gain full outer shell or noble gas electronic configuration. And they do so by three ways: either by transfer of electron between a metal and a non-metal. So that is ionic bonding, which is between metals and non-metals. Covalent bonding is the sharing of the electron between two nonmetals, and metallic bonding is between the metals, where there's an electrostatic force of attraction between fixed positive ions and delocalized electron. So if any formula is given to you, you can easily say whether it is an ionic and covalent bonding, seeing what atoms are bonded. So if in carbon dioxide there's carbon and oxygen, which are found to the right side of the periodic table, they are two nonmetals, so that is covalent. Ammonia is nitrogen and hydrogen, which are again two nonmetals, so that is covalent. Nitrogen is nitrogen, which is covalent. Water is covalent. Sodium chloride is sodium, which is to the left side, and chlorine, which is to the right side. So this is ionic. Calcium fluoride is ionic. So just by looking at the formula, you can also say whether it's ionic, covalent, or metallic bonding. Now, what is ionic bonding? Ionic bonding is between a metal and a non-metal, and you should understand how you draw the dot and cross diagram. So in dot and cross diagram, you do three things. First of all, write the elements and write their electronic configuration and write their outer, just draw their outer electron. So aluminium is 283, fluorine is 27. So in aluminium, I've drawn 3 electrons with a dot or a cross, or the other one with the dot or a cross, and then I'll choose 7 electrons. Now, aluminium has to get rid of 3. So 1 electron from an aluminium goes to fluorine because fluorine just needs 1. But that makes aluminium to lose 2 more. So it takes the help of 2 other fluorine. So you'll draw the outer electron, show the arrow. So first write the symbol, write the electronic configuration, show the outer electron, show the transfer. And then write the charges. As aluminium has lost 3 electrons, it has got 3 plus charge, and fluorine has got 1 minus charge, but there are 3 fluorines. And this is how you need to draw the dot and cross. Remember, write the electronic configuration, show the outer electrons, and show the transfer. Okay, now whatever we have drawn, we'll write that in a definition. So ionic bonding is between a metal and a non-metal. The metal is losing an electron to a non-metal, and as metal is losing an electron, it is getting a positive charge. Non-metal gains an electron and becomes a negative charge, and there's an electrostatic force of attraction between an opposite charge ion, resulting in ionic bonding. So metal loses an electron and becomes positively charged. Non-metal gains an electron, becomes negative charge, and there's a strong electrostatic force of attraction between opposite charge ion, resulting in ionic bonding. So I hope this dot and cross diagram is clear to you. Now let us take another example of magnesium and chloride. Magnesium chloride. So I'll write the first electronic configuration. Magnesium is 282. Chlorine is 287. Then I'll draw the outer electron. For the outer electron, my magnesium, I'll show 2 electrons, and chlorine, I'll show 7 electrons. So that's my next diagram. Magnesium, I'll show 1, 2 electrons. Chlorine, I'll show 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Magnesium will be losing 1 electron to chlorine. Magnesium has to get rid of 1 more, so it will take another help of the chlorine. And then what will happen at the end, magnesium has lost 2 electrons, will have a +2 charge. Chlorine has 7 electrons, 1, 2, 3, 4, 5, 6, 7, and a dot with a -1 charge, and there are 2 chlorines. So ionic bonding is between metal and non-metal. Metal loses an electron, remember, and becomes positively charged. Non-metal gains an electron and becomes negatively charged. There's a strong electrostatic force of attraction between opposite charge ions, resulting in ionic bonding. Next is, you should know what are the properties of the ionic compound. They are brittle solid with definite crystal shape. They are good insulators in solid forms but becomes good conductors. This is very important in liquid or dissolved form. High melting and a boiling point compared to the molecular bonds. Now the reason for these property you should know. So in ionic compounds, there's a strong electrostatic force of attraction between an opposite ions. This results in the formation of giant ionic lattice. Now, why it is a conductor in a liquid form? In solid form, the ions are not free to move as they are held together by strong electrostatic force of attraction. In molten or when they are dissolved in water, the ions are free to move and conduct electricity. And why they have a high melting and a boiling point? Again, because there's a strong electrostatic force of attraction between opposite charged ions. It forms a giant ionic lattice. So large amount of energy is required to overcome these strong electrostatic force of attraction. Therefore, they have a high melting or a boiling point. Okay, so this is how you explain the properties of ionic compounds. However, if I asked you to compare whether aluminium chloride, magnesium chloride, or sodium chloride, which one will have a greater melting point, it depends on charge. Greater the charge, strong will be the electrostatic force of attraction. And remember, aluminium forms 3 plus, magnesium forms 2 plus, sodium forms plus 1. So since aluminium has a greater charge, it will have a stronger ionic lattice. So aluminium chloride will be more stronger as compared to magnesium chloride as compared to sodium chloride. Okay, so I hope this is clear to you. Now next is how to write the ionic formulas. To write the ionic formulas, the step is you write the symbol, write the charges. Up to group 4, the charge is same as the group number. After group 4, it is group number, take away 8 and then do crisscross. For example, if I gave calcium and calcium oxide. Now, write the symbol, so that is Ca. Oxygen, calcium is in group 2, so charge is 2 plus. Oxygen is in group 6, so 6 minus 8 gives a 2 minus charge. Since both charges are same, they get cancelled, so the formula of calcium oxide is CaO. Sodium oxide, sodium is in group 1, has a plus 1 charge. Oxygen is 6, 6 minus 8 is 2 minus, then you crisscross, 2 of oxygen comes underneath sodium and 1 of sodium come underneath oxygen. Remember, it's the numbers that get crisscrossed. Generally, we do not write 1, so the formula would be Na2O. Then work out magnesium nitride. Magnesium is group 2, so that is 2 plus. Nitrogen is group 5. 5 take away 8 is minus 3. And then you do crisscross. 3 of nitrogen comes underneath magnesium. 2 of magnesium come underneath nitrogen. So this is Mg3N2. Okay, so please try all of them and then you should get sodium sulfide to be Na2S, sodium chloride to be NaCl, magnesium chloride to be MgCl2 and aluminium chloride to be AlCl3. Okay, now these are all the symbols that you can get from your periodic table. However, there are some complex ions which you do not get from the periodic table. You need to remember their charges. I have tabulated this for you here. Make sure you remember them. If you're finding hard to remember, put it on your study room, see it every day, and you will memorize them. Ammonium is NH4 plus, hydroxide is OH minus, carbonate is CO3 2 minus, sulfate is SO4 2 minus, nitrate is NO3 minus, phosphate is PO4 3 minus. Now magnesium hydroxide, you know Mg is group 2, so that is 2 plus. Hydroxide is OH from minus 1, you crisscross. Remember, in the complex ion, you have to draw the bracket because it's the OH that gets 2. So the formula would be MgOH2. What is the formula of aluminium sulfate? Aluminium is 3 plus, SO4 is 2 minus. We do the crisscross. Aluminium will get the 2 of sulfate, so it will be Al2. The whole sulfate gets a 3 number. So you put SO4 entire in a bracket and you write 3. Okay, so in this way you can get calcium phosphate as Ca3 PO42. Magnesium nitrate is MgNO3, which is 2. Calcium carbonate is CaCO3 and sodium phosphate is Na3PO4. So I hope how to work out the formulas of ionic compounds with complex ions is clear to you. And ionic bonding. Now let's move on to covalent bonding. It is between two nonmetals. It shows the sharing of electron. More than one electron pair gets shared, it will become double or the triple bond. Now what you do is you draw the circle, Draw the outer electrons, one with the dot, one with the cross, and see how much electrons both needs to gain full outer shell and share that in the middle. For example, hydrogen has one, needs one more, so you put one electron at the center. Chlorine also needs one, so you put one chlorine electron at the center and draw the rest on the rings. Chlorine each need one, so you draw one electron of each at the center and make the rest. Water, between an oxygen and hydrogen, there's a sharing of one electron each. Nitrogen and hydrogen, between each of these circles, sharing of one electron. Carbon and hydrogen, one electron each. But nitrogen both needs three electrons to complete the full outer shell, so you draw 3 electrons in the center. Similarly, oxygen needs 2 electrons, so you draw 2 at the center. Carbon, oxygen, you draw 2 each at the center. So oxygen is a double bond. Carbon and oxygen is a double bond. Nitrogen and nitrogen is a triple bond. Okay, so I hope these dot and crosses are clear to you. Please make sure you understand them because they are often asked in the exam. Okay, now since we have done covalent compounds, we should know the properties of them. Covalent compounds are classified into simple molecular and giant covalent. Simple molecules are oxygen, chlorine, and methane. They have weak intermolecular forces between them, therefore they have low melting and a boiling point. However, their intermolecular forces increases with size, so therefore polymers which have covalent bonding between them, high melting and a boiling point due to their chain length. Whereas diamond, graphite, and silicon dioxide are the examples which have a giant covalent structure, therefore they have strong melting and a boiling point. Now, ionic compound, let's compare the difference between ionic and the covalent compound. Ionic compounds are crystal, covalent are solid, liquids, and gases. Ionics have high melting and a boiling point, covalent have lower melting and a boiling point. Ionics are hard and brittle, covalents are poor conductors. Ionic usually are soluble in water, covalent are not. Ionic undergo electrolysis and covalent are flammable. Okay, so now let us see the giant covalent structure, diamond and graphite. This is the difference between them. Diamond has a hard, rigid structure, whereas graphite has a layered structures. So diamond is hard, has a high density. Graphite is soft and greasy, lower density. In graphite, 3 electrons are bonded to form a ring and 1 electron is localized for each carbon. These delocalized electron make it a good conductor. So diamond is an insulator, graphite is a conductor. In diamond, each carbon atom is covalently bonded to 4 other carbon, giving it a strong rigid structure. In a graphite, carbon atoms are bonded in the form of layer, in the form of hexagon. No covalent bonding between the layers, so they can easily slide past each other. And each carbon is bonded with 3 other carbon, leaving the 4 electron delocalized. So diamond has no delocalized electrons used in cutting or in jewelry. Graphite has delocalized electrons. It is used in pencil lids. Okay, so I hope the structure of diamond and graphite is clear to you. Now they can ask you this question: why graphite is tough and slippery, or why graphite conduct electricity. So in graphite, carbon atoms are bonded in the form of layers, in the form of hexagon. No covalent bondings are between the layers, so they slide past each other. The layer have only weak intermolecular forces between them. So by applying a little pressure between the layers, they can slide past each other, making graphite soft and slippery. On the other hand, in graphite, carbon's atoms are bonded in the form of layer, in the form of hexagon. No covalent bonding is present between the layers, so they slide past each other. Each carbon atom is bonded with 3 other carbon, leaving the 4th electron as delocalized. And these delocalized electrons are mobile electrons which move and conduct electricity. Okay, then there are other 2 allotropes of carbons which are there in your syllabus. It's a fullerene, which is a hollow shaped molecule having hexagonal rings like a buckyball, also known as Buckminster fullerene. Carbon can be in the form of pentagon or the hexagon ring, and it is used as catalyst, drug delivery, or treating cancer. Graphene is a layer of interlocking hexagonal ring like a shingle sheet of graphite. It is light, rigid, 100 times stronger than steel, perfect thermal conductor. It is a better conductor than graphite, light and have low density. Therefore, it is used in making copper chips, computer chips, and flexible electronic display. Okay, and then we have carbon nanotubes, which looks like this. They are cylindrical fullerene with the length greater than the diameter. They have a high tensile strength, so they are used in making reinforced composite materials, and they have a high electronic conductivity, therefore used in electronic conductivity or industries. Now comes the last bonding, which is the metal. It is between two metals, you can see they are fixed positive ions in the sea of delocalized electrons. There are layered structure forming a giant lattice, and there's a strong intermolecular forces, strong electrostatic forces between the opposite charge ions and the delocalized electron, resulting in metallic bonding. You should be able to draw this diagram and explain these points. Fixed positive ion, delocalized electron, as you have a lot of properties on the basis of them. So what are the properties? Metals are malleable. What is the meaning of malleable? They can be hammered into any shape. Metals are ductile, means they can drawn into wires. They are good conductors of electricity, and they have high melting and a boiling point. So why metals are malleable? Because the metals have layered structures. They can slide past each other just by little hammering. Ductile, again, because they have layered structure, they can be hammered. They are good conductors of electricity because there are mobile electrons. There are delocalized electrons which can conduct electricity. And due to strong electrostatic force of attraction between fixed positive ion and delocalized electron, they have high melting and a boiling point. Next is a very important concept of an alloy. You can see this is a pure metal having a layered structure. When you mix it with another metal or a non-metal being different in size, it interlocks these spaces so the metals can no longer slide over each other. Example, steel is the alloy of the iron, which is more strong and resistant to corrosion. So in metals, the particles are arranged in layers. There's a regular arrangement of fixed positive ions which can slide over each other by applying pressure. However, in alloys, there's a mixture of metal with another metal or a non-metal. Another metal being different in shape and size distort the regular arrangement of the metal ion. As a result, the layers can no longer slide past each other, making a metal strong. Next, you have a concept of nanoparticles. These are the particles that are size 1 to 100 nanometer. Now, 1 meter is 10 to the power 9 nanometer. Okay, so 1 nanometer is 1 times 10 to the power minus 9 meters. Now, how do we get to know to this calculation? You need to remember this chart. It's killing metal milo Mickey nano pictures. Km, milli, micro, nano, picometer, and all of them are 10 to the power 3. So from kilometers to meter, you time by 1000, meters to millimeters times by 1000, and when you go reverse, you divide by 1000. So if you need to convert the nanometer into meter, so you go from here to here, there are 3 bumps, so you divide it by 10 to the power 9. So 1 nanometers is 10 to the power minus 9 meter. For example, convert 10 nanometer to meter. So nanometer to meter is divided by 10 to the power 9. So 10 divided by 10 to the power 9 is 10 to the power minus 8 meter. Convert 10 nanometer to micrometer. So now let's see how you do that. 10 nanometer is here, micrometer is here. They both have divided by 10 nanometer to micrometer. So this is a 10 nanometer, this is millimeter. So if you are converting 10 nanometer to a millimeter, you divide it by 6. So that becomes 10 power minus 5 meters. So I hope this is clear to you. Now, why nanoparticles are important? Because as the size decreases, the air surface area to volume ratio increases. Therefore, nanoparticles being very small size have large surface area to volume ratio, making them very useful in science and medicine. You can see if you have a cube of 1000 meters, its surface area would be 6 times 1000 by 1000, which is 6 times 10 power 6, and volume would be 10 to the power 9. So surface area to volume ratio is 6 times 10 power 3. On the other hand, when you have 100, then the surface area to volume ratio is 6 times 100. So with an decrease in size, surface area to volume ratio increases. Therefore, nanoparticles are very important, being having high surface area to volume ratio. So, as we have seen that the nanoparticles have high surface area to volume ratio, they have a variety of uses. They're used in medicines for drug delivery or to kill cancer and tumor cells. They're used in cosmetics, to use in sunscreen to block sunlight. They're used in household as self-cleaning window panes. The nanoparticles are coated with materials when light falls in them. They carry out a reaction and breaks the dirt, and which is washed away by water while raining. And being having large surface area to volume ratio, they are used in small quantities, so they are very effective as a catalyst. However, there are a lot of risks of nanoparticles due to small size. They can cause difficulty in breathing. They can accumulate in the environment and cause air pollution. Due to their large surface area, a small spark can result in violent explosion, making them risky to use. They're toxic and cause breathing and respiratory problems. Due to their small size, they can also cause water pollution and risk the aquatic life. Okay, so I hope all these types of bondings with their properties are clear to you. Now, there are three states of matter, which is there in your syllabus. I think you must have remembered from your key stages. 3, 4 particles in solids are closer together, have fixed shape, strong forces between the particles, definite volume, cannot be compressed and cannot flow. On the other hand, liquids are slightly closer, do not have fixed shape, there's weak forces between the particles, have fixed volume, can be compressed and can flow. And gases, the particles are far apart, do not have fixed shape, they have weak intermolecular forces, do not have fixed volume, highly compressibles, and can flow. So you can see solid particles are very closer to each other. Liquid, they're little far apart. In gas, they are very far apart. And solid can be converted to a liquid by melting, reverse freezing. Gas can be converted to a liquid by condensation, and liquid can be converted to a gas by evaporation. Okay, now this is the curve that whenever you increase the heat, the solid temperature is heated, and at the melting point, the temperature remains the same until all the solid converts into a liquid. Then, when the change of state happens, the material, the temperature increases, then the liquid converts into a gas, and at a boiling point the temperature remains the same until all the liquid converts into a gas, and then at boiling it converts into a vapor. Okay, so I hope all these terms, all this topic is crystal clear to you. Now there's a time for the key terms we have seen in this topic. Okay, so now let us revise what are all the key terms that we did in this topic. So we talked about ions, ionic bonding, dot and cross, covalent bonding, metallic bonding, intermolecular forces, joint covalent molecules, polymers, delocalized electrons, fullerene, graphenes, alloys, nanoparticles, nanoscience, states of matter, solid, liquids, and gases. Ions are the charged atoms with unequal number of protons and electrons. Ionic bonding is between metal and a non-metal, which involves transfer of electrons between a metal and a non-metal. Dot and cross is a diagram that shows transfer of electrons in an ionic bond or sharing of electrons in a covalent bond. Covalent bonding is the bonding between two non-metals, which involves sharing of electron. Metallic bonding is a bonding between fixed positive ions and delocalized electron. Intermolecular forces is the forces between the molecules which determines the melting or boiling point. Giant covalent molecules are the covalently bonding molecules with a giant structure. Polymers is made up of many repeating units. Delocalized electrons are the mobile electrons which are free to move. Fullerenes is an allotrope of carbon which form a cage-like structure like buckyball. Graphene is the allotrope of carbon which is equivalent to single layers of graphite. Alloys are the mixtures of metal with another metal or a non-metal. Nanoparticles are the particles which are the size 1 nanometer to 100 nanometer. Nanoscience is a branch of science that deals with nanoparticle. States of matter are different form of states that a matter can take, solid, liquids, and gases. Solids are the states of matter with fixed shape and volume. Liquids are fixed shape but not fixed volume. Liquids and then states of matter without any fixed shape and fixed volume is the gases. Okay, so I hope this is clear to you. Next is test yourself. So you need to show the name type of bonding in sodium chloride, magnesium, nitrogen, carbon dioxide, water, and ammonia. Draw dot cross diagram to represent sodium chloride, water, and magnesium. Differentiate between diamond and graphite. Why ionic compounds do not conduct electricity in solid. Why alloys are stronger than metals. Why aluminium has strong melting point than sodium. And what are nanoparticles, give its properties and application. Okay, so sodium chloride is ionic, magnesium is metallic, nitrogen is covalent, carbon dioxide is covalent, water is covalent, ammonia is covalent. Dot and cross diagram, sodium chlorine, you will search 281, 287. Transfer of electron from sodium to chlorine, sodium will get +1 and chlorine will get -1. For magnesium, there's a fixed positive ion in the C of delocalized electron, and charge of magnesium is 2 plus, so you will put 2 plus. Difference between diamond and graphite: it's hard, insulator, high density. Each carbon is covalently bonded to 4 other. No delocalized electron used in cutting or jewelry. Graphite is soft and greasy. Conductors lower density than diamond. Carbon is bonded in the form of flare, in the form of hexagon. It has delocalized electron used in pencil leads. Why ionic compounds do not conduct electricity in solid? Because in solids, the ions are not free to move. Alloys are stronger than metals because the different size atoms distort the regular arrangement, so they cannot slide past each other. Aluminium has stronger melting point than sodium because of its greater charge. It has greater charge, greater number of electrons, so greater charge density, so stronger electrostatic force of attraction. Nanoparticles are the particles of size 1 to 100 nanometer. Due to smaller size, they have high surface area to volume ratio, making them useful in medicine, catalyst. Now, whenever we talk about organic chemistry, we basically talk about hydrocarbons. Now, what are hydrocarbons? Hydrocarbons are the compounds which are made up of carbon and hydrogen only. And from where do this hydrocarbon comes? It comes from crude oil. Now, crude oil is a black thick liquid which takes millions of years to form. And the best part is that different components of the crude oil have different boiling points, so you can separate them by the process known as fractional distillation. Remember this word, fractional distillation, as often in the exam they ask you to explain and even explain the term fractional and distillation. So let's see. Now, before we come into fractional distillation, let us see what are the different properties that each of the components of the crude oil has. Now, the properties of the crude oil, it depends on the chain length. So, if the chain length increases, the boiling point increases. Now, what is the boiling point? It is a temperature at which hydrocarbon boils. It increases with increase in chain length. Why? Because greater the chain length, greater the surface area between the molecules, and higher the boiling point. Next is volatility. Volatility is a property that how quickly it can convert into a vapor. And naturally, lower the boiling point, more volatile the substance would be. So with increase in chain length, the volatility decreases. Next is viscosity. Viscosity is thickness of the fraction, and naturally greater the chain, greater is the thickness, so the viscosity increases as the chain length increases. And last property is flammability, or the property of ignition, which is how quickly something burns, and it decreases with increase in chain length, because longer the chain length, it is difficult to burn that molecule or the hydrocarbon. So the chain length increases from top to bottom, the boiling point increases, the volatility decreases, viscosity increases, and flammability decreases. So you should know what is the meaning of all these terms and how they vary across the chain length. Now, this is the fractionating column for the fractional distillation of crude oil. Now, remember the important bits in here. At the top, we have a low temperature, and at the bottom, we have a higher temperature. So at the top, we get shorter chain fractions, and at the bottom, we get a longer chain fractions. Okay, now, what is fractional distillation? Fractional distillation is separating in the fractionating column with different substances of similar boiling point. So each fraction has the components or the hydrocarbon with a similar boiling point. So fuel oil is one fraction, diesel oil is one fraction. And distillation is separating on the mixtures of boiling point. So the crude oil has all the components which differs in their boiling point. So we can use this property by taking a fractionating column and maintaining the series of temperature. At the bottom, the higher temperature, and at the top, the lower temperature. Now we heat the crude oil at a very high temperature and put it inside this crude oil at the bottom. The vapors will start to rise, and the shorter chain ones, which has the lower boiling point, they will condense at the top, followed by the medium chain and the higher boiling point liquids at the bottom. Okay, now what are the different fractions? You need to remember these different fractions in the order. So at the top, we get liquefied gas, then we get gasoline, then kerosene, diesel oil, and residue. The liquefied gas is used as a fuel. Gasoline or petrol is used for car fuels. Kerosene is used for aircraft fuels. The diesel oil is used in diesel engines and residues making roads. The mnemonic to remember that is look great, kid doing roll. So L stands for liquefied gas, G stands for gasoline, K stands for kerosene, D stands for diesel oil, and R stands for residue. So you should know this fractional distillation setup. Which temperature is at the top, which is at the bottom? What are the various fractions we get? In what order? Where do we get shorter chain fractions? Where do we get longer chain fractions? And the uses of these fractions. So this slide is very, very important. Okay, next we have another technique called cracking. Now, what is cracking? As the name suggests, crack means to break. So cracking is the thermal decomposition of the longer chain hydrocarbon into a shorter chain alkane and an alkene. So you can look in this example. We have 1, 2, 3, 4, 5, 6, 7 hydrocarbon long, and we broke them into 2 carbon ethene and then 5 carbon shorter alkene. Now, why do we do cracking? And this question is also asked in the exam many times. So we do cracking because we need short chain alkanes, because shorter chain alkanes are more in demand because they're good fuels. And the fractional distillation alone cannot fulfill the demands of shorter chain alkane. The second thing is why we require cracking is we require alkenes for polymerization, and alkenes are required to synthesize other hydrocarbons, which fractional distillation cannot give. Okay, so you should know what is cracking. In the exam, they can give you any compound. They can ask you, write the name, write the formula for 20 carbon hydrocarbon. So 20 carbon alkane would be, we'll see later, it has the formula CnH2n plus 2. So that would be C10H42. You need to do its thermal cracking. So remove an alkene which has a C2H4 formula, and then you are left with 18 and 38 hydrogen. So they can ask you to write a cracking equation. Why is cracking done? And what are the ways in which we do cracking? Either we give a high temperature, that is thermal cracking, or we use a catalyst, which is a catalytic cracking. Okay, so I hope this cracking concept is clear to you. Now let's see what are hydrocarbons. The first family of hydrocarbons is alkanes. How do we define alkanes? You have to define it by using the word saturated hydrocarbon. Saturated means it contains carbon-carbon single bonds. You can see all these molecules has carbon-carbon single bonds. And hydrocarbons, because they are made up of carbon and hydrogen only, the general formula is CnH2n plus 2. So the first member would be CH4, C2H6, C3H8, C4H10, and pentane C5H12. So whatever the number of carbon is, you double it and add 2 for the number of hydrogen. Now, if you look at methane, ethane, propane, butane, all these members, they have the same functional group, that is, they all have alkanes. They show similar chemical properties and they have the same general formula. But they will have different physical property. As you can see, methane has 1 carbon, so it will have a shorter boiling point as compared to pentane, which is a longer hydrocarbon. So all these members differ in physical properties, and each next member differs. So you can see in this homologous series, they have the similar functional group, similar chemical properties, same general formula, but one member differs from the successive one by 1 carbon and 2 hydrogen. So CH4 add 1 carbon 2 hydrogen gives C2H6. C2H6 add 1 carbon 2 hydrogen is C3H8. So this is what is the definition of homologous series, and it is often asked in the exam. So make sure you remember this. So homologous series are the members of the same family having similar functional group, similar chemical properties, general formula, but different physical property, and each member is different from successive by CH2 group. Now, next is reaction of alkanes. Now, alkanes show only 2 types of combustion, complete and incomplete. What is a complete combustion? Combustion is when the fuel is completely burned. So hydrocarbon plus oxygen give carbon dioxide and water, and it is not toxic as it is not producing any harmful gases. On the other hand, incomplete combustion is when the fuel is partially burned due to limited supply of oxygen. So the hydrocarbon, it burns to give carbon monoxide and water. Now, it is toxic as carbon monoxide is a toxic gas. It decreases the oxygen carrying capacity of the red blood cells. Therefore, it is very harmful and a toxic gas. So incomplete combustion is harmful. So in the exam, you should be able to write the equations of complete and incomplete combustion. Remember, incomplete, take the carbon dioxide and water out. And in incomplete, write carbon monoxide and water and balance the equation. Okay? Now, the next thing we need to do is How will you test the product of combustion? Now, combustion gives carbon dioxide and water. For carbon dioxide is a lime water test. You do the combustion reaction, the gas level is boiled, you pass it through a lime water, it will turn lime water milky. For the water test, you take anhydrous copper sulfate, and when you add water to the anhydrous copper sulfate, it will turn blue. Or you pass the water through blue cobalt chloride paper and it will turn pink. So cobalt chloride and copper sulfate is both the test of combustion products. Now let's see what are functional groups. Now we have seen hydrocarbons, and alkenes are hydrocarbons. At times, apart from hydrogen and carbon, you get some other atoms like alcohols as OH, carboxylic acid has COOOH and COO. These groups of atoms which give special properties and reactions to the organic molecules are functional groups. And you have 4 functional groups in your syllabus. Alkenes, which is a double bond. An example is ethene, propene, butene, and pentene, and we can form it by cracking of crude oil. Alcohols is a hydrocarbon chain with an OH, and we name it with all. So 1 carbon alcohol is methanol, 2 carbon is ethanol, propanol, butanol, and pentanol, and we can make alcohol by reacting alkene with water or steam. And carboxylic acid is COOH, which is methanoic acid, ethanoic acid, propanoic acid, butanoic acid, and we get them by oxidation of alcohols. And esters is methyl ethanoate, ethyl ethanoate, and we get it by the reactions of alcohols and carboxylic acid. So now let us see all of them in detail. Now what is alkene? Now since alkene has a double bond, which makes it unsaturated hydrocarbon. So alkenes are unsaturated hydrocarbons, that is the compound made up of carbon and hydrogen only, where a carbon-carbon double bond is present. General formula is CnH2n, and it is used to make polymers, alkanes, and alcohols, and we'll be seeing next how we can do that. So it always starts with ethene, then propene, then butene, and pentene. So you draw the number of carbons, put double bond, and remember each carbon can make 4 bonds. So fill the rest of the valencies of rest of the carbons with the number of hydrogens, and you will see that the carbon and hydrogens, they'll be in the ratio 1:2. Okay. Now, what are the reactions of alkene? This is very important. Okay. Watch it very, very properly and make sure you are able to write these reactions. First is combustion. Combustion is both complete and incomplete. So you can take any alkene, react it with oxygen. If it forms carbon dioxide and water, it is complete combustion. And if it forms carbon monoxide and water, it is incomplete combustion. Then it shows addition reactions. Now, what are the addition reactions? When you react it with halogen, then the double bond breaks into the single bond, and these 2 molecules, they attach to each side of the double bond. So when you take an ethene, you react it with bromine water, and this is a test to distinguish between alkane and alkene. The bromine water is orange yellow in color, and if you pass it through alkenes, it will turn clear. So alkenes decolorizes bromine water. So you take alkene and then you react it with bromine, the double bond breaks into the single bond and bromine attach here. Similarly, when you react it with hydrogen, the double bond breaks into a single bond and each hydrogen attaches to each side. So alkene becomes alkane, and here you use nickel catalyst at 60 degrees. For water, when you react it with water, the double bond breaks into the single bond and hydrogen goes on one side, OH goes on one side, so ethene produces ethanol. So by addition reaction from alkane, you can get haloalkanes, you can get alkanes back, and when you use water, you can get alcohols. Okay, so these are all the reactions of alkene. Make sure you are able to write these whole reactions. Okay, next is very important, manufacture of ethanol. Now, ethanol is an alcohol which we get either by fermentation of glucose, that is anaerobic respiration of glucose, or we have just seen when you take ethene and pass it through water, you get ethanol. So that is hydration of ethene. Now, hydration of ethene required nickel catalyst and a high temperature and pressure, whereas for fermentation, we require gentle temperature and pressure. The advantages of fermentation is, since you're using glucose or the plant-based sugar products, this reaction uses renewable resources, so it is less dependent on fossil fuels and make less harms and have less energy requirements. On the other hand, when you do hydration of ethene, it takes ethene from crude oil and it uses non-renewable resources. But the advantages of hydrogen of ethene is it's a continuous process. You can just put everything in a mixture and keep the reaction going on. It is rapid, more efficient, make more pure ethanol, and since it is the only product, it has 100% atom economy because it has no side products. On the other hand, fermentation is a batch process. You cannot make the reaction go on because as soon as the alcohol concentration increases, it will kill the yeast. So you need to do make certain quantity of alcohol and distill off and then do the reaction again. So the reaction is slow, produces impure ethanol, and the atom economy is not 100%. So both of these processes has its own advantages and disadvantages, and in the exam they'll ask you to explain for both the methods, and you have to explain the reaction condition, advantages and disadvantages. So make sure you remember this table and contrast the benefits of each of the methods and disadvantages. Next is alcohols. Alcohol have the functional group OH. The general formula is CnH2n plus 1 OH. So if you take N as 1, the first carbon is methanol with CH3OH. 2 carbon is ethanol, 3 carbon is propanol, 4 carbon is butanol. So you have 1 carbon with OH and then 3 hydrogen, 2 carbons with OH and fill the rest of the valencies with OH. And the alcohols are used as fuels, solvents, and spirits. Okay, so I hope what are alcohols is clear to you and you're able to draw the displayed formula and the general formula of different alcohols. Now, the reactions of alcohol, first is combustion. As we have done alkenes, so all hydrocarbons choose a combustion reaction. In a complete combustion, ethanol or any alcohol with oxygen give carbon dioxide and water. And in incomplete combustion, any alcohol with oxygen give carbon monoxide and water. Next is the oxidation. When you oxidize an alcohol, it converts into an corresponding carboxylic acid. So methanol will convert into methanoic acid, ethanol will get converted into ethanoic acid, propanol will convert into propanoic acid. And for this, you require an oxidizing agent, which is generally the potassium dichromate. And alcohol, basically, they act as like an acid. So they react with the metal to form a salt and hydrogen. So alcohols react with metal to form a salt and hydrogen. So here we have ethanol with calcium and it forms calcium ethanoate plus hydrogen. Okay, so I hope all these reactions are clear to you. Next we have the carboxylic acid. Carboxylic acid have the functional group C double bond OH. So 1 carbon is HCOH, which is methanoic acid. 2 carbon is CH3COH, which is ethanoic acid. 3 carbon is CH3CH2COH, which is propanoic acid. And butanoic acid is CH3CH2CH2COH. Now, carboxylic acid are considered as weak acid, and they'll ask you in the exam, why is it a weak acid? So you have to give this definition that weak acids are those which are partially dissociated in water to release H plus ions. And then you have to give this equation, CH3COH breaks into CH3CO minus plus H plus. Now, since it's an acid, it reacts with metal oxides and hydroxide to form salt and water, and it reacts with carbonate to form salt and carbon dioxide and water. Okay, so I hope you remember these reactions and why carboxylic acid is a weak acid. Next is an esters. Esters are the last functional groups you need to know. It's the fruity smelling compounds which is used in the manufacture of perfume, foods and cosmetics. They are formed by the reaction of carboxylic acid and esters to form esters and water. Now, how will you name the ester? Whatever the alcohol is, write its name as IL and carboxylic acid as OH. So, for example, if you take methanoic acid and methanol, the alcohol becomes alkyl, so that is methyl, and carboxylic acid, methanoic acid become methanoate. In the same way, ethanol plus methanoic acid, alcohol becomes yle, so that is ethyl, and methanoic acid becomes methanoate plus water. And to write its reaction, you will write the methanoic acid and methanol facing each other, remove the molecule of water, and whatever is left, join it together. Similarly, ethanol and methanoic acid, join them together, whatever is left, move the water, that will be your ester. Okay, now we have done the functional group. Now the last thing you need to do is the polymers. Now what are polymers? Now if you see in this figure, this is an individual unit and you can see this is repeated, and this repeating unit is a polymer. So the individual unit that polymerizes to form a polymer is known as a monomer. Example, ethene. So ethene is a monomer, and the structure formed by the polymerization of the monomer is the polymer. Example, polyethene. So you can see CH2 double bond CH2 is an ethene and it forms this polymer. Now I'll tell you the trick how you need to write the polymer equation. Always write the ethene or any alkene molecule such that there's a double bond in the center and all the groups are at the top, at the bottom, nothing to the left and the right side. And when you polymerize this structure, remove the double bond, draw the bars at the end, and then write N. That becomes a repeating unit. So for example, if the ethene molecule is given to us, then this will be our ethene, and I'll write N in front of it. And to make the polymer, I'll convert the double bond into single bond, join it to the ends, and then write N in the bottom. Now, ethene is simple. For example, you have propene. So what is the structure of propene? Propene is 1, 2, 3 carbon and a double bond, right? This is what is the structure of propene. Right? Now, how I will write it. As I told you, you will always draw this double bond at the center. So at the center, I'll draw C double bond CH, and this has 2 hydrogens. And this carbon has 1 hydrogen. And then it has CH3, so I'll write CH3 at the top. So I have it in this notation. I'll polymerize it, that is N molecule. And then when I make the polymer, I'll remove the double bond into single bond, join it with the ends, and then all the group remains the same. So if you write the notation always in this form, that a double bond in the center and everything at the top and the bottom, then the polymerization equation would be very easy for you. So you should know how to write polyethene, polypropene, and polybutene. So addition polymers, they are formed by addition reaction. They require only one monomer. Generally, it's an alkene. Nothing is lost in the reaction. Example, polyethene and polypropene. The other types of polymerization, we have a condensation reaction. It requires 2 monomers and 2 functional groups. For example, we have this molecule. We are representing it with the box as a schematic representation, has an OH at both ends, and then other molecule has C double bond OH at both ends. Now, when we put them together, we will remove the molecule of water by a condensation reaction. So OH, the hydrogen will be lost here and the OH will be lost here. So what we are left with, O, and then C double bond O, and again C double bond O. So you can see that this is the new bond that is formed by a condensation reaction. So we have 2 functional groups facing each other. We have removed the molecule of water. A small molecule like water is lost. Example, nylon or polyester. This is between alcohol and carboxylic acid. So this is a polyester. An example is nylon. Okay, so this is a difference between addition and a condensation polymers. Addition requires 1 monomer. It requires 2 monomers or 2 functional group. In addition, nothing is lost. Here, a small molecule is lost. Addition polymers are formed by addition reaction. They are formed by condensation reaction. Now we have some natural polymers. They are found naturally. For example, complex biomolecules. Starch is a polymer made up of glucose, and protein is also a polymer made up of amino acids. So it's the other way around. The polymer is the protein and it is made up of amino acid, and the DNA is the polymer made up of nucleotides. So you can see this is an individual glucose unit. Either they join by a straight chain or a branch chain and give rise to starch, glycogen, or cellulose, which are the natural polysaccharides. And these individual glucose are the monosaccharides. And 2 amino acids. Amino acids have the carboxylic group and an amino acid group together, amine group. When they join together, a molecule of water is lost and it forms a peptide bond, and they are the condensation polymers. DNA is a polynucleotide we have done in biology, so it's just a brief recap. Nucleotide means a phosphate, sugar, and a base. So you can see a phosphate, sugar, base. Phosphate, sugar, base is repeated. In a DNA, the sugar is deoxyribose. Phosphate and nitrogenous bases are for adenine, thymine, guanine, and cytosine, and they show complementary base pairing principle. With adenine next to it is thymine, and with guanine next to it is cytosine. Okay, so I hope all this concept of organic chemistry is clear to you. Now you should have a go at these key terms: hydrocarbons, crude oil, fractional distillation, alkanes, saturated hydrocarbon, unsaturated hydrocarbon, general formula, viscosity, flammable, volatility, fractions, complete combustion, incomplete combustion, cracking, thermal decomposition, alkenes, functional group, homologous series, addition reaction, alcohols, carboxylic acid, esters, fermentation, weak acid, monomers, polymers, polymers, addition polymerization, condensation polymerization, monosaccharide, polysaccharide, starch, cellulose, proteins, and DNA. Have a go at these terms. If you're still unclear, watch the video again and then come to the website and check the answer. So as always, our next step, check the specification, make sure everything which is there in the specification is still clear to you, and do exam questions on this topic. Okay, and do not forget to subscribe to my channel and hit the bell icon so that you get notified as soon as I put a new video. And if you have any doubts, leave a comment below and I'll reply you as soon as possible. So I'll see you next in the next video. Till then, happy revising.